Okay, this is video 8 in the test 1 review, and we're going to move on to imperfectly coupled inductors. But I was going to just mention as a final note, on the ideal coupled transformers, you could have scenarios where, for instance, you could have either several transformers, cascaded together, right, like this, say. You might have an R1 and an R2 and an N1 to 1 and N2 to 1. And, in a case like this, or you could have something where they're in parallel, right, where you could have one transformer. So this is R1, N1 to N2. Then let's put one in parallel here, like that. This is N2 to 1. Of course, this one here could be redrawn as potentially just a transformer that has two windings. Okay, where they will say this is an N1 to 1, and then this one is maybe it'd be better to write it as 1 to 1 over N1, and this one is 1 over N1. This is 1 over N2. Okay, and you can do the same thing, and you just deal with one transformer at a time. We could take this and reflect it over, so we'd have an R2, and now when we reflect that resistor over, we'll have R1 times N1 squared. And then we could take this and reflect this back to the primary, where now we would have R2 times N2 squared plus N2 squared times R1 times N1 squared. All right, so now this is VA here, then we have VA at this point. Similarly, over here when they're in parallel, you could reflect R1 to the primary and reflect R2 to the primary, and what we'd end up with, call this VB, is we'd have VB with a resistor R1 times N1 squared, but then in parallel with that, we would have a second resistor, which would be R2 times N2 squared. Okay, so just because we're looking at just single transformer circuits, it doesn't mean you can't apply this to, a 2 or 3 transformer circuit. Okay, actually, let me stop here, and I'll start the next video looking at coupled inductors that are imperfectly coupled.